The interstellar object known as 3I/Atlas has become one of the most perplexing cosmic discoveries of the decade, drawing unprecedented attention from astronomers, physicists, and independent researchers who are struggling to categorize its nature and behavior. When it first appeared as a faint streak against the dark backdrop of distant space, the initial assumption among scientists was that the object was simply another comet traveling along an elongated trajectory. Its seeming luminosity and the faint trail behind it supported this classification. However, as more sophisticated instruments were aimed in its direction, the early hypothesis quickly began to unravel. High-resolution imagery from multiple observatories revealed that the object's structure did not conform to any known pattern associated with comets or asteroids. Instead of a stable nucleus shedding dust and gas in predictable arcs, 3I/Atlas seemed to be undergoing a series of structural changes that suggested internal forces far more complex than sublimation, the usual mechanism behind cometary disintegration. Sections of its body appeared to fracture, rotate, and realign while somehow maintaining a steady trajectory through space, as though each piece remained gravitationally or magnetically tethered to an unseen core. These strange movements created inconsistencies in the calculated mass, raising doubts about whether the object was solid, hollow, porous, or composed of unknown materials. The dependence on reflected light to determine mass and density became problematic, because the brightness of the object fluctuated in ways that could not be explained solely by its distance from the sun. As a result, astronomers were forced to reconsider whether the object's luminosity was being influenced by transient surface features, shifting angles, or even external energy interactions. Energy and spectral measurements added to the mystery. Analysis suggested that the density of 3I/Atlas was significantly higher than that of typical cometary bodies, which are usually made of fragile mixtures of ice, dust, and loosely packed rocky material. Instead, the readings hinted that the object might possess a core with properties closer to metallic or composite structures, provoking speculation that its origins could differ drastically from any known interstellar debris. Some researchers argued that the density could be the result of intense cosmic radiation compressing the body over millions of years, while others suggested exotic compositions formed in extreme environments, such as the outskirts of dying star systems or regions with unusually strong magnetic fields. Although most experts dismissed the idea of an artificial object, the combination of high density, anomalous movement, and inconsistent reflectivity inevitably pushed conversations into more speculative territory. Further intrigue arose when instruments detected a striking blue hue in several early image sequences. At first, this coloration led observers to speculate that the object might contain frozen methane, ionis silica, or other unusual compounds that might produce such visual effects when exposed to sunlight. Some even theorized the presence of exotic minerals capable of refracting light in unexpected ways. However, meticulous review of the imaging data determined that the blue tint was not an inherent characteristic of 3I/Atlas. Instead, it was partly the result of sensor distortion caused by the angle of solar reflection and the specific wavelengths captured by the imaging devices. Although this clarification eliminated one layer of mystery, it reinforced the notion that the object was behaving unpredictably under observational scrutiny, making it difficult for researchers to distinguish between genuine features and observational artifacts. What truly propelled 3I/Atlas to global scientific prominence, however, was the detection of faint but rhythmic radio signals emanating from its vicinity. Multiple observatories, using independent equipment and located on different continents, reported capturing emissions that appeared to follow a repeating pattern. Natural radio emissions from comets, asteroids, or interstellar debris typically fluctuate randomly as charged particles interact with solar wind. But these signals seemed organized, steady, and persistent enough to raise immediate questions. Teams of radio astronomers spent weeks cross-checking data to ensure the signals were not the product of interference, atmospheric noise, or technical malfunctions. While no consensus has been reached, early findings suggest that the emissions could be produced by ionized gases or charged particles becoming energized as the object passes through varying levels of solar radiation. Even so, the rhythmic nature of the signals continues to puzzle experts, as no previously studied interstellar object has shown this degree of consistency in radio output. Comparisons to Oumuamua, the first recorded interstellar visitor, were inevitable. Observers noted that while Oumuamua displayed unusual acceleration and a curious cigar-like shape, it did not produce rhythmic radio signals, nor did its surface appear to shift or realign in real time. In contrast, 3I/Atlas exhibits a combination of structural instability and electromagnetic irregularities that make it even more enigmatic. Some researchers argue that the object may be rotating in an uneven manner, causing its fragmented pieces to reflect sunlight in a way that mimics radio modulation. Others believe the radio emissions might originate from surrounding plasma rather than the object itself. However, the ongoing inability to fully decipher the pattern leads a small minority of theorists to consider more unconventional possibilities, including interactions with unknown cosmic phenomena or mechanisms not yet understood within the framework of current astrophysics. Adding to the challenge is the inherent difficulty of observing an interstellar object traveling at tremendous speeds while constantly changing its orientation relative to both Earth and the Sun. Even the most advanced telescopes struggle to capture stable, distortion-free images of such a fast-moving target. In addition, variations in the object's trajectory, possibly caused by outgassing, internal shifts, or external magnetic forces, introduce further complications into modeling its movement. The object's brightness fluctuates unexpectedly, forcing astronomers to continually recalibrate their estimates of size, reflectivity, and rotation rate. These inconsistencies have led to ongoing debates about whether 3I/Atlas is gradually breaking apart or merely shedding layers in a pattern that defies traditional understanding of cometary decay. Beyond the technical challenges, the object has sparked philosophical discussions within the scientific community about the limits of observational astronomy. If a relatively small interstellar body can exhibit such a wide range of unanticipated behaviors, it calls into question how much of the universe remains misunderstood or undetected. Some experts argue that objects like 3I/Atlas may be far more common than previously believed, but only now are observational instruments sensitive enough to detect their anomalies. Others propose that our expectations of interstellar travelers are shaped too heavily by limited knowledge, given that humanity has only discovered a handful of such objects across the entirety of recorded history. Despite the excitement, most astronomers continue to maintain a cautious perspective. They emphasize that natural explanations, though perhaps complex or novel, are far more likely than artificial or extraordinary ones. As more data is collected from ground-based telescopes and orbital observatories, researchers hope to determine whether the radio signals are produced by transient phenomena, such as solar-wind interactions, or whether they reflect a deeper, more persistent mechanism intrinsic to the object itself. Understanding the source of the rhythmic pattern remains one of the top priorities for ongoing research, as decoding the signals may reveal essential clues about the composition, magnetic environment, and internal processes of 3I/Atlas. For now, the object continues its silent journey through space, leaving behind a trail of questions that challenge existing theories of cosmic formation and behavior. Whether 3I/Atlas ultimately proves to be a rare natural phenomenon or a completely new category of interstellar body, its discovery has already expanded scientific curiosity and highlighted the need for more advanced tools capable of capturing the complexities of the universe. As it moves farther from Earth, researchers remain determined to track and analyze it for as long as possible, driven by the hope that somewhere within its shifting fragments and faint radio pulses lies insight that could reshape our understanding of the cosmos.